Okay, so continue tayo sa kuan. Next topic we have here the thermodynamic property in which this is enthalpy. Okay, so enthalpy is one of the properties um one of the properties of our substance or systems that is also given on our table, on our appendix, no, sa dito sa ginagamit natin na libro. Okay, so enthalpy is being derived, no, by using once again the no, if you read this discussion here, enthalpy is being derived if we assume that the pressure is constant. Okay, so that's why the integration of work from 1 to 2 or from state 1 to 2 is magiging kuan na lang siya, magiging P V1 P V2 minus V1. Okay, so therefore no, yun, so madiderive na natin yung enthalpy by using the energy equation, assuming that the potential and kinetic energy are zero. Okay, so yun, makukuha na natin yung enthalpy. Okay, so as you can see here, enthalpy is equals to internal energy plus pressure and velocity, or specific enthalpy is equals to specific internal energy plus P multiplied by specific volume. Okay, so equation number 3.28. Okay, so throughout this discussion here, malalaman nyo that the enthalpy can only be used provided that the pressure is constant. Okay, um, but not only limited for that case, no, may mga possibilities na pwede nating gamitin uh, yung enthalpy na yan even if the pressure is not constant by some consideration. Okay? So, basahin lang natin to siya at makikita natin kung paano or kung bakit. Okay? So, but in here, okay, makikita natin dito that enthalpy is also the same with our internal energy at saka yung specific volume. Parehas pa rin, okay? Parehas pa rin sila ng computation, meron din silang X, meron din silang enthalpy ng saturated liquid at saka enthalpy ng saturated vapor. So yun, at saka gumagamit din tayo ng equation na to, okay? As you can see here, familiar sa atin to siya, okay? Itong equation na H is equals to HF plus X HFG, no? Nagamit natin yun siya if I'm not mistaken sa specific volume at saka sa internal energy, okay? Okay. So dito tayo sa example number 4. So example number 4, we have a cylinder fitted with a piston has a volume of 0.1 meter cube and contains a 0.5 kilogram of steam at 0.4 megapascal. Heat is transferred to the steam until the temperature is 300 degrees Celsius. Okay? While the pressure remains constant. Okay? So, ibig sabihin nito, given yung state 1 natin, then nag-transfer tayo ng heat so that yung kuan natin, yung steam natin is lumaki yung kanyang temperature, no? Heat is, no, we have here, basahin natin ulit ha. A cylinder fitted with a piston has a volume of 0.1 meter cube and contains a 0.5 kilogram. So, given yung state 1 na mass of steam. Take note of this one na steam yung binanggit dito. At 0.4 megapascal. Heat is transferred to the steam until the temperature is 300 degrees Celsius while the pressure remains constant. Okay, take note here that pressure is remains constant, so therefore we can apply the enthalpy. Okay, if the enthalpy is yun yung hinahanap. Okay, so sabi dito, determine the heat transfer and the work for this process. Okay, so hahanapin daw natin yung heat transfer at saka yung work na nangyari dito sa process sa system natin. Okay? So yun. So we have here step 1, control mass. We have control mass is lahat ng water na inside cylinder. Steam actually. Okay? Then process is contact pressure. We have P2 is equals to P1, no? Constant pressure. P2 is equals to P1. Then initial state, given yung mass natin, given yung pressure 1 natin at saka yung given din yung volume natin. Okay? Therefore, specific volume at state 1 can be found from our table. Okay? Um, Yun. So, we have here at P1 V1 check stream. Okay? So, for us to be able to find V1, we have to check if P1 V1 can be found or in between from the in between the same tables. Okay? Two phase region, no? So, meron tayong saturated liquid at saka saturated vapor. So, kung in between doon sa dalawa, so ibig sabihin nun, doon natin makikita yung specific volume natin at state 1. Okay? So, final state. Okay, so siguro nalilito kayo kung saan ano yung tinutukoy ko ng ah, mga table, no? Yung table na tinutukoy ko is yun yung table na binigay ko sa inyo nung sa if I'm not mistaken sa module 2 natin, okay? Or sa instructional material 2 natin, nandoon yun siya. Okay, maraming table yun siya. So makikita nyo doon yung table B.1.1, B.1.2, B.1.3, B.1.4 at saka B.1.5. So once again, B.1.1 is at saka B.1.2 is yun yung steam table, yun yung doon yung two-phase region, yun yung pinagsamang saturated liquid at saka saturated vapor. Yung B.1.3 naman siguro is yun yung subcooled liquid at saka yung B.1.4 is yun yung if I'm not mistaken, yun yung superheated vapor. Then for same with B.1.5. Okay, so tingnan nyo lang doon actually yung minimin ko na mga value. Okay, so itong V1 dito sa initial state, makukuha natin to siya doon sa it's either sa B.1.1 at saka sa B.1.2. Okay? So yun. So final state, we have P2, T2. Therefore, state 2 is fixed. Okay? So makukuha din natin yung V2, no? Specific volume at 2. So, diagram is in figure 3.23. Ito yung diagram natin. Okay? Ito yung kung paano na-derive yung kuan. Tapos, model is steam table pa rin. Okay? So, analysis. There is no change in kinetic energy once again or potential energy. So, we can neglect that two quantities sa energy equation natin. Tapos, work is done by movement at the boundary. Assume the process to be quasi-equilibrium process since the pressure is constant. So, we have uh, work from 1 to 2 is equals to integral of PdV from 1 to 2, which is equals to P integral from 1 to 2 dV, or it is equals to PV2 minus V1. Okay, so yun, constant yung P natin, no? So, we have here mass times P2, specific volume at phase 2, at state 2 minus P1 specific volume at state 1. Okay, so yun. So as you can see here, no? Um no, itong derivation na to sa kuan natin, itong derivation na to sa ito, itong part na to. So ito yung derivation ng enthalpy, okay? Or specific enthalpy in terms of heat. So, i-follow lang natin yun siya. So, yun, makuha na natin yung answer. Solution, uh, so, ganun pa rin, no? Makukuha pa rin natin yung V1, no? Specific volume at state 1, yun once again, by using the mass at saka yung volume. Then, after nun, okay? After nun, titingnan natin siya sa kuan, titingnan natin siya sa steam table if this V1 here is in between uh, if this V1 here, itong V1 na to is in between VF and VFG, VF and VG. So if in between doon, so makukuha natin yung X1. Okay, so after that, so since in between talaga doon kasi steam to siya na condition, so in between talaga, so makukuha natin yung X1, no? So pag makuha na natin yung X1, we can also find the H1 by using the HF at saka HFG. Yung HFG is makukuha din natin sa table at saka yung HF. Okay? So nakuha na natin yung X1. So uh, therefore, we can now find the value of H1. Okay? Now, for H2 naman, okay, same as this one, makukuha din natin. So, therefore, we can now find the value of transfer of heat here. Okay? Then, the same for our work na MPV2 minus V1, makukuha natin din yun siya by using the specific volume for state 1 at saka specific volume for state 2. Okay? So, therefore, makukuha natin yung change of internal energy then U1 at saka U2 makukuha din natin, okay? So, yun. Basahin lang natin yun siya. Okay.